Yesterday we saw two-way ANOVA. Okay, how to perform two-way ANOVA. Today we are going to see that how to perform MANOVA. I am not going into to show you three-way ANOVA or four-way ANOVA or n-way ANOVA, because the procedure is same. Okay, and you can do it using Minitab or any kind of this kind of software. You can perform this thing. So rather I am going to show you MANOVA. Okay, or today I am going to discuss two-way MANOVA. MANOVA means multivariate analysis of variance. Okay, now so you can understand that there cannot be one-way ANOVA. Okay, one-way MANOVA. If you talk about one-way MANOVA, it will simply become one-way ANOVA. Okay, why? Because actually in you have seen that in one-way ANOVA there is one dependent variable and one independent variable. In case of two-way ANOVA, there is one dependent variable like test score, and there are two independent variables like the gender and age groups. Okay, but in MANOVA, if you talk about two-way MANOVA, that means just wait. Okay, so if you talk about two-way MANOVA, that means you are having one independent variable, and you are having two dependent variables. For example, the independent variable can be teaching method, and the dependent variable can be test score and satisfaction score. Okay. Similarly, in case of three-way ANOVA, you will have one independent variable and three dependent variables. Okay, and so on. So in four-way MANOVA, four-way MANOVA, you will have one one independent variable, and there will have four dependent variables. Okay, so in this way you will be dealing with MANOVA. So you can understand that ANOVA is very general. That means you are having only one dependent variable and one independent variable. So there is no such thing called one-way MANOVA. It is not possible. Okay. So usually in research work, the kind of research work that is performed in management-oriented research work, MANOVA is not very common. Okay. You mostly you deal with ANOVA or even two-way ANOVA. Okay, and also you do some post hoc tests. Okay. And also, even if you use MANOVA, maximum you are interested in two-way MANOVA. Okay. So let's take a look at the concept. Okay. So suppose we are studying three different teaching methods for a course. This variable is our independent variable. We also have student satisfaction scores and test scores. These variables are our dependent variables. We want to determine whether the mean scores for satisfaction and tests differ between the three teaching methods. Okay, we want to determine whether the mean scores for satisfaction and tests differ between the three teaching methods. Okay, or alternatively we can also say whether there is an association between the uh, you know uh, the teaching methods and the relationship of the satisfaction and test score. So the graph below display the scores by teaching method. One chart shows the test scores and the other shows the satisfaction scores. These plots represent how one-way ANOVA tests the data one dependent variable at a time. Okay. So you just have a look at this one. Okay. So both of these graphs appear to show that there is no association between teaching method and either test scores or satisfaction scores. The groups seem to be approximately equal. Consequently, it's no surprise that the one-way ANOVA p-values for both test and satisfaction scores are insignificant. You can see 0.923 and 0.254. Okay. So what you are actually performing? See, first have a look at this graph. You are using three different teaching methods. This is one teaching method. This is the second teaching method. This is the third teaching method. And along y-axis, we are representing the test scores. Okay. And you are plotting all the data. Okay. Using teaching method 1, the test score that you are having. Using teaching method 2, the test scores that you are getting. Using teaching method 3, the test scores that the students are getting. So you are plotting those data. So you are not observing any kind of trend or any kind of good pattern in this data. It's not like, suppose using the teaching method 1, that if the test scores are less, using the teaching method 2, the scores are moderate. Using the teaching method 3, most of the scores are very high. Okay. So this kind of trend, you are not, this trend or this kind of pattern, you are not observing from this data. The data are scattered throughout the maximum, from the beginning to the maximum test scores. The data is scatteredly, it is located. Okay. So you cannot make any conclusion out of it. Similarly, the same thing is also happening for the satisfaction. Okay. You are seeing that you are using teaching method 1, you are using teaching method 2, you are using teaching method 3. Okay. So these three teaching methods you are using, and you can see that the satisfaction score, you are having the satisfaction score, and you cannot see any such kind of pattern from which you can conclude that one particular teaching method is effective for the satisfaction of the students. You are not observing that kind of thing. Okay. So teaching method is not uh, affecting actually the test score or the satisfaction score. Okay. And that is all, that is you are getting also from one way ANOVA. If you carry out one way ANOVA, your null hypothesis will be like the teaching method affects do not affect test score, and teaching method affects test score. So you cannot reject your null hypothesis. Okay. So the same thing will also happen for the teaching method and satisfaction. Teaching methods do not affect the satisfaction, and teaching method affects the satisfaction. You cannot reject the null hypothesis. Okay. You can have a look at your p-values. But the teaching method isn't related to either satisfaction or test scores. But hold on, there is more to this story. But there are something is hidden that we can see from the next slide. So this is the next slide. Here you are plotting along x-axis, you are plotting the satisfaction scores, and along y-axis you are plotting the test scores. Okay, this is the scatter plot of test versus satisfaction, and the blue dots are representing teaching method 1. The brown dot is representing teaching method 2, and the green dot is representing teaching method 3. This graph displays a positive correlation between test score and satisfaction. You can see it very clearly from this graph that as your satisfaction increases, your test scores also increases. As student satisfaction increases, test scores tend to increase as well. Moreover, for any given satisfaction score, teaching method 3 tends to have higher test scores than method 1 and 2. You can see from that graph that the green dots are above the blue dots or the brown dots. Okay. And the green dots are representing the teaching method 3. Okay. So in other words, students who are equally satisfied with the score, with the course, tend to have higher scores with method 3. You can see from, suppose if somebody's satisfaction score is 3, okay, if you consider 3 students who are going through 3 different teaching methods, okay, one student will have the satisfaction level, one student who has the satisfaction level of 3, he will get the score like 3 also. Okay, because he is going through the method of 1, teaching method 1. Okay. Now, if you look at this dot, you will see that the same satisfaction score, this student has same satisfaction score, but he is getting more test score because he has gone through the teaching method of 2, and this student he has the same satisfaction score, but he is getting more test score, highest test score, because he has passed through the method of teaching method of 3. Okay. So MANOVA can test this pattern statistically to help ensure that it's not present by chance. Okay. So what the, how can you do it? So let's take a look at this about MANOVA test statistic. You have seen the test statistic in ANOVA, and similarly you can also, there are some test statistics in MANOVA, but due to the multivariate nature, there is no single or unique solution for MANOVA. You can have different test statistics like Pillai stress, Wilks lambda, Hotling, Lolly trace, Roy's largest root. There are different test statistics. So you don't need to go through in very much details about those statistics, because you can, using your software, you can uh, perform the tests very easily, and you can also get the p values. Okay. So the closest f values are given for the test statistics, and you are getting the p values. You are seeing that it is, in all cases, all statistics are revealing that it is significant. Okay. So even though the one-way ANOVA results and graphs seem to indicate that there is nothing of interest, MANOVA produces statistically significant results as signified by the minor scale p values. We can conclude that there is an association between teaching method and the relationship between the dependent variables. Okay. So that means, what I'm trying to say, that using MANOVA, here you are in this, from this case study, you can understand that your satisfaction level is not influenced by the teaching method. The test score, that is also not influenced by the teaching method, but the relationship between the teaching method and the satisfaction score, that is influenced by your independent variable teaching method. Okay. So if you consider one particular dependent variable, you are seeing that that is not influenced by your independent variable. Okay. But if you consider the relationship, that is influenced by the type of the independent variable, by the type of the independent variable. Okay. So this is the conclusion. Okay. So now I will show you one thing that I have previously told you, that a very crucial thing about, I will give you one particular example, and using that particular example, I will show you all the story. So that I am going to share with all of you. Okay. So hopefully you are able to see this. Okay. So several research scholars, they have requested me that when to perform which test, how can I understand? Okay. And I think the best possible way to understand it, giving a particular case study, okay, and so that you can look all the tests at a glance, okay, that will be easier for you to understand, okay. So consider this case, okay. You can see that I will share you this particular Word file. I will share with all of you. I will share it in the WhatsApp group. Suppose in a class 36 students have registered for unit test 1, okay, unit test 2 and unit test 3, okay. You can see that 36 students have registered for unit test 1, 36 students have registered for unit test 2, and 36 students have registered for unit test 3. But in unit test 4, 54 students have registered. In unit test 4, 54 students have registered, okay. In unit test 4, you can see that 54 students have registered, okay. 54 students have registered for unit test 4. Now in unit test 1, unit test 2, unit test 3 and unit test 4, you have got the test scores for 36, 18, 18 and 36 students, okay. That means in unit test 1, 36 students have registered for the course, and you have got the scores for all 36 students. That means for the entire population. You can also see that in the unit test 2, 36 students have registered for the course, and you are actually you have not got the score of all 36 students. Suppose you have taken a sample from only 18 students. Similarly, in case of unit test 3, 36 students have registered, but you have got the scores for only 18 students. You have got the sample size. And in case of unit test 4, 54 students have registered, and you have got the sample of 36 students. The rest of the students are not tested, okay. And in case of unit test 1 and unit test 2, these are non-existing, because only 36 students have registered for the course. So all the other courses are non-existing, okay. Now in this column, the gender and age are being represented. B means boys, G for girls, 10 means 10 years old, 11 means 11 years old, and 12 means 12 years old, okay. And also the mean and the standard deviation, these things are also given to you, okay. This population, it will be, you can delete it, or even we can take it sample population, but these are all about sample, so you can match this scale, okay. So this is the case, Now, the traditional teaching methodology is known as teaching method 1, which is offline based. Okay. So the traditional teaching method you have used before unit test 1, that is offline based teaching method. Okay. And then the scores obtained in unit test 1 by all 36 students or population are presented below. Here it is, all the things are presented. Now, suppose you have used a new teaching method online based, which is termed as teaching method 2A before unit test 2, and you have got a sample of 18 students scores. Okay, you have used a new teaching method 2A before unit test 2, and you have got the scores like this, and this is your sample. In case of unit test 1, you have taken the scores for all the population, but in case of unit test 2, 3 and 4, you have only taken samples, not, you don't know the entire population. Then you have introduced another online based sub method, that is 2B, teaching method 2B for teaching before unit test 3, and you have drawn samples of test scores from the same 18 students. So before unit test 3, you have you have implemented the method teaching method 2B, and you have your sample size is the same 18 students scores you are observing after the teaching method 2B. Okay. And you have finally you have adopted another online based sub method 2C. This for teaching, where you have implemented another teaching method 2C before unit test 4 for teaching, and you have drawn samples from 36 students. You can see that 36 students. Okay. Okay. Scores represented within brackets under UT4 are the satisfaction scores. That means not only the test scores you have collected, you have also collected the satisfaction scores which are represented within brackets. Okay. There are two genders, boys and girls. Teaching method, age and gender are independent variables, while scores obtained is a dependent variable. Okay, scores obtained is a dependent variable. Okay, so now have a look at which particular tests need to be performed in which case. Suppose in one sample Z test, okay, Uday Kiran was asking for to give an example of one sample, another example of one sample Z test and T test. So please take a look at this one. Say, suppose the mean score of all 36 students or population in unit test 1 is 8.389. Okay, you know the mean score is 8.389, and the standard deviation, you know also the standard deviation, that is 3.458. This is your standard deviation. Okay, so after implementing a teaching method 2A, 18 student samples are tested in unit test 2, and you get the sample mean as 9 and standard deviation as 3.43. So do you think that the new teaching methodology is effective? Or alternatively, you can also say that do you think that the mean score has changed as compared to the past 8.389. Earlier, the mean score was 8.389. This is the population mean. And now after implementing the teaching method 2A, you are having the score of mean is 9. But this is not the population mean. This is, you are getting the sample mean. You don't know about the population. So can you say that your population mean has changed as compared to the previous mean of 8.389? Okay. So to ensure that the new teaching methodology is effective or influencing, so in order to understand this type of concept, you should use one sample Z test. Okay. Now take a look at one sample T test that I have also discussed. This is also just like the one sample Z test that I have discussed just now. The same thing. You want to understand the effectiveness of teaching methodology, whether the teaching methodology is effective or whether the mean is differing from the earlier mean. Okay, you are obviously talking about the population mean, but you don't know the standard deviation of your earlier population. Okay, you don't know the standard deviation. That means this 3.458, this was the standard deviation, okay, of the population earlier. But in this case, you don't know that your population is 3.458. It will be 3.458. This population standard deviation, it is not known. Okay, so in this case you will perform one sample T test. Okay, now take a look at the independent sample T test or student's T test. When you will perform this kind of test, do you think that there is a significant difference between boys and girls mean scores in unit test 2? Okay, take a look at this sample, unit test 2. Okay, you have taken some samples. Some samples are from boys and some samples are from girls. Okay, so for boys you will get an average or mean. For the girls you will get a mean. Okay, but from this particular sample, but the difference that you are getting from the sample, whether that difference is also applicable for the population, that you would like to test. Here the gender is independent. Okay, the gender boy will not depend upon the girl, or the gender girl doesn't depend upon boy. Okay, so in this case you are implementing independent sample students T test. That means you are taking samples from two different groups and you are comparing the mean of those groups at sample level in order to conclude about population level difference of mean. So you are utilizing or you are implementing here the independent sample or students T test. Now you can see that dependent sample or paired sample T test. When you are using dependent sample T test or paired sample T test, after implementing teaching method 2B, again same again sample testing is done in unit test 3 for the same students. Is teaching method 3 effective, or is teaching method, sorry, 2B, it will be, is teaching method 2B, after implementing teaching method 2B, again sample testing is done in unit test 3. Is teaching method 2B effective, or whether population means same for two groups of unit test 2 and unit test 3. Okay. So here what you are doing, you have got this course in unit test 2. Now after implementing the teaching method 2B, you are getting this kind of test scores from the same sample. That means one is before and another is after. So when you will take sample from the same students or from the same people, okay, and you will implement some methodology or some particular medication, and you will see the effect before and after. During that time you will be using the dependent sample t-test or paired sample t-test. This is very, very useful for drug oriented research work, because very often in suppose you have discovered a particular drug, in that case it is noticed that what is the effectiveness of that particular drug. You take the responses before implementing the drug and you take the responses after implementing the drug. Okay, so it's just like same before this teaching methodology 2B and after that using the teaching method 2B. Okay, so this mean and this mean, whether they are different at population level, that you are trying to test. So this is your dependent sample or paired sample t-test. Less than 1 minute is remaining, so we can join again. Once it is closed, then we can again join. Okay, it is now less than 1 minute. So then F test we need to perform. When we should perform the F test? Okay, so earlier we have seen that so far we have compared the mean, okay, the average, that we have compared. But whenever F test is performed, it compares the variances. Is there any difference